Let's see this. Here we go. Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All righty, today we're going to go on to take a look at section 8.5. But before we do that, do any of you that are here have questions you'd like to look at from WebAssign? Anything at all? Anybody? Okay. And we'll go ahead and get started in section 8.5. Today we're going to look at solving absolute value equations. So let's start off by reviewing what an absolute value is. Okay, an absolute value is the distance between a number and 0 on the number line. So for instance, let's say we've got this number line and we've got the number 8 and the number -8. Okay. The distance between 8 and 0 on the number line is 8. The distance between -8 and 0 on the number line is also 8 because distance is not negative. Distance is either positive or in the case of how far is it from 0 to 0, distance is 0. The notation we would use would be two vertical bars. So we'd say the absolute value of 8 is 8. The absolute value of -8 is also 8. And as I mentioned a second ago, the absolute value of 0 is 0. So an absolute value is never negative. It's either positive, the distance between it and 0 on the number line, or 0 in the case of the absolute value of 0. All right. Any questions before we go on? Okay. Let's say we have the following equation. The absolute value of x equals 7. Okay. So what numbers could we put inside the absolute value bars for which the absolute value of that number would be 7? Well, the absolute value of 7 is 7. The absolute value of -7 is also 7. So for this equation, the absolute value of x equals 7, we get the following two answers. Absolute value of x is 7 and x is -7. It could be both of those. Any questions about that situation? All right, let's take a look at another situation. The absolute value of x is 12. So either x would be 12 because the absolute value of 12 is 12, or x could be -12 because the absolute value of -12 is 12. So we get these two answers to this absolute value equation. All right. Suppose we have the absolute value of x plus 3 equals 10. Well, what's inside the absolute value bars would have to either equal 10 or -10, right? Because the absolute value of 10 would be 10. The absolute value of -10 would also be 10. So that produces these two equations. But unlike the previous cases, we need to go on and solve these. So for x plus 3 equals 10, subtracting 3 from both sides of the equation, we get x is 7. For x plus 3 equals -10, subtracting 3 from both sides, we get x equals -13. Let's go back and check our answers. If x is 7, we would get the absolute value of 7 plus 3 equals 10. The absolute value of 10 equals 10. 10 equals 10, so x equals 7 checks. Let's see if x equals -13 checks. The absolute value of -13 plus 3 equals 10. The absolute value of negative 10 equals 10, but the absolute value of negative 10 is 10. 10 equals 10. So x equals negative 13 also checks. So we have two solutions to this absolute value equation. Any questions so far? Okay, let's take a look at this one. The absolute value of 2x minus 5 equals 20. So that means what's inside the absolute value bars has to either equal 20, or what's inside the absolute value bars has to equal the opposite of 20, or negative 20. To solve the first equation, add 5, 2x equals 25, divide by 2, x equals 25 halves. To solve the second equation, add 5, 2x equals negative 15, divide by 2, x equals negative 15 halves. Let's check our work. Let's check our answers. So this one, going in here, we would get the absolute value of 2 times 25 over 2 minus 5 equals 20. Well, 2 times 25 over 2, the 2's would simplify out, giving us 25. 25 minus 5 is 20, and the absolute value of 20 is 20. So 20 equals 20, and this one checks. The second one, if x is negative 15 halves, the absolute value of 2 times negative 15 halves minus 5 equals 20. The 2's reduce out. Negative 15 minus 5 is negative 20, but the absolute value of negative 20 is 20. So once again, 20 equals 20, and that solution also checks. So again, we get two solutions. You might be seeing a pattern where we keep getting two different solutions. Well, let's look at a case where that isn't true. Let's say we've got the absolute value of x minus 4 equals 0. Well, that means what's inside either has to equal 0 or has to equal the opposite of 0. But what is the opposite of 0 or negative 0? It's just 0. So these two equations are basically the same equation. So in this case, where we have an absolute value equal to 0, we only get one equation leading to one solution. If x is 4, we get what? The absolute value of 4 minus 4 is 0. Absolute value of 0 equals 0. 0 equals 0, and it checks. So in that case, we get one equation producing one solution. All right, what about this case? Let's see here. Oh, let's go back to black ink there. The absolute value of x minus 3 equals negative 7. Well, let's see. This would mean that either x minus 3 has to equal negative 7, or x minus 3 equals the opposite of negative 7, which is what? Positive 7. So solving the first equation, we add 3 and we get x equals negative 4. Solving the second equation, we add 3 and we get x equals 10. Okay, let's check our work. Let's take this one. If x is negative 4, we get the absolute value of negative 4 minus 3 is negative 7. Negative 4 minus 3 is negative 7, but the absolute value of negative 7 is 7. So we get 7 equals negative 7. Doesn't work. Okay. Second equation, if x is 10, the absolute value of 10 minus 3 equals negative 7. 10 minus 3 is 7. The absolute value of 7 is 7. 7 doesn't equal negative 7. So we get no solution. Now, recall earlier in reintroducing this idea, I said that absolute value can't be negative. So the absolute value can't be negative, which is why there's no solution. Now, ordinarily, I would say if you could look at this and determine there's no solution because you have an absolute value set equal to a negative number, you could just go to the finish line and say no solution. But WebAssign sometimes asks you to find those extraneous solutions, again, those solutions that don't work. So you may have to go through the motions and then conclude that, oh, this answer doesn't work. Let's read the directions. Okay. Now, what if we have this situation? We have 2 times the absolute value of x plus 5 equals 25. Okay. Up until now, each of the examples I've given you on the left side of the equation had just an absolute value. But now we have an extra multiplier outside of the absolute value. Before you break it down into two separate equations, the first thing you want to do is isolate the absolute value. Okay, so in this case, the first move would be to divide both sides by 2. Okay, now we get what's inside has to equal 25 halves, or what's inside has to equal the opposite of 25 halves. Going from there, we'll subtract 5 from both sides. So we get x equals 25 halves minus 5, which is 25 halves minus, 10 halves, taking minus 5 over 1, multiplying it by 2 over 2 to get a common denominator. So then we get 25 halves minus 10 halves, which is 15 halves. Okay. Second example, x plus 5 equals negative 25 halves. Subtract 5 from both sides. X equals negative 25 halves minus 5, which will multiply by 2 over 2. X equals negative 25 halves minus 10 halves, which is negative 35 halves. So we get what? X equals 15 halves, x equals negative 35 halves. Here again, the point being, you need to isolate the absolute value before you break it down into the possible 2 equations. Okay, let's look at another example of that. Let's say we've got the absolute value of 2x plus 10 plus 6 equals 14. So your first move is going to be to isolate the absolute value. So we'll subtract 6 from both sides. Then we get what? The absolute value of 2x plus 10 equals 8. Now we break it apart and say either 2x plus 10 equals 8 or 2x plus 10 equals the opposite of 8. And then from there, solving each equation. Subtract 10 from both sides, 2x equals negative 2, divide by 2, x equals negative 1. Subtract 10 from both sides, 2x equals negative 18, divide by 2, x equals negative 9. Let's see, let's check the x equals negative 1. We'll put that right here. We'd get what? The absolute value of 2 times negative 1 plus 10 plus 6 equals 14. 2 times negative 1 is negative 2. Negative 2 plus 10 is 8. The absolute value of 8 is 8. So 8 plus 6 is 14. 14 equals 14. That one checks. Let's take this one and check it up here. Negative 9. The absolute value of 2 times negative 9 plus 10 plus 6 equals 14. 2 times negative 9 is negative 18. Negative 18 plus 10 is negative 8. The absolute value of negative 8 is 8. 8 plus 6 is 14. 14 equals 14. So that one also checks. Any questions there? All right. Another scenario. Let's say we've got 2 absolute values equal to each other. So we've got absolute value of 6x equals the absolute value of x plus 45. Well, if we take what's inside the first one and set it equal to what's inside the second one, we get one scenario. If we take what's inside the first one equal to the opposite of what's inside the second one, we get another scenario. If we take the opposite of the first one equal to what's inside the second one, we get a third scenario. And finally, what's inside the first one equal to the opposite, or excuse me, the opposite of what's inside the first one equal to the opposite of what's inside the second one, we get a fourth scenario. So it appears as though we have four different equations. However, notice something. If we were to take this equation, okay, and multiply both sides by -1, we would have this bottom equation. So in fact, they are the same equation, so we don't need that. Likewise, if we were to take this equation and multiply it by -1, we'd get this equation. So we don't need this one. So what does that give us? Well, let's see here. Let's erase all this extra stuff. It boils down to what's inside of the first one equals what's inside of the second one, or what's inside of the first one equals the opposite of what's inside of the second one. So taking those two examples, and I'm going to rewrite this bottom one over here. Interesting. There we go. Now it's working. So now solving these two equations, let's see, what would we do? We'd subtract x from both sides. 5x equals 45. Divide both sides by 5, x equals 9. Over here, we'll distribute -x minus 45. So then we will add x to both sides. 7x equals -45. Divide by 7, x equals -45 sevenths. Okay. Well, let's check our work. Tell you what we're going to do, because I'm going to run out of room. Well, I'm going to check the first one on this page. I think I can put that one in here. So we're going to take that one. We're going to get the absolute value of 6 times 9 equals the absolute value of 9 plus 45. 6 times 9 is 54. The absolute value of 54 equals the absolute value of 54. So 54 equals 54. So the first one checks. I'm going to recopy this and put that in to check it in on the next page. So we've got the absolute value of 6x equals the absolute value of x plus 45. And we're going to put in x equals -45 sevenths. All right, so let's check it. So 6 times -45 sevenths equals -45 sevenths plus 45, absolute value. Okay, wow. 6 times -45, it's too early in the morning to figure that out in my head, so I'm going to cheat and use my calculator. Not that it's cheating, but 6 times -45, this becomes -277. Okay, now -270 divided by 7 doesn't come out nicely, so I'm just going to say the absolute value of -277 would be 277. Okay, on the right side, I've got to take, let's see, -45 sevenths plus 45 over 1, which I would then multiply by 7 sevenths. So I get -45 sevenths plus, let's see, 45 times 7 is 280 plus 35, what, 315? So that's 315 sevenths. But -45 plus 315 would be 270 sevenths. So this equals the absolute value of 277, which is 277, and so it checks. Amazingly so. All right. So if you have an equation with two absolute values, you want to have them separate, one on each side of the equation. And then you have the two possibilities. What's inside of the first equal to what's inside the second. What's inside of the first equal to the opposite of what's inside of the second. If you have a single absolute value, you want to isolate it completely before you do anything else. If there's a coefficient in front or an extra term, get rid of them so you have just the absolute value of whatever equals whatever. From there, you can split it apart into possibly two equations. If it's equal to a positive number, you're going to get two equations. If it's equal to 0, you're going to get one equation. If it's equal to a negative number, you're going to create two equations, but neither one of them are going to give you a correct answer. But if it asks you to find those extraneous solutions, you would go through the motions. But always, always, always check your work at the end to make sure what's going on. Okay, let's see here. I thought I had, here we go, some with some decimals involved. So let's take a look at that. Let's say I've got the absolute value of 4x minus 24.8 equals 32.4. So we have an isolated absolute value equals a positive number. So we're going to get two possibilities. 4x minus 24.8 equals 32.4, or 4x minus 24.8 equals the opposite of 32.4. So let's see, solving the first equation, I'm going to add 24.8 to both sides of the equation. So I get 4x equals, let's see, that's going to be 57.2. 57.2. Yeah, dividing by 4, let's see, 57.2 divided by 4. 57.2 divided by 4 is 14.3. Okay. Second equation, we're going to add 24.8. So then we get 4x equals negative. Well, let's see if we have negative 32.4 plus 24.8, we get negative, oops, already have a negative 7.6. Then dividing by 4, negative 1.9. Okay, so let's check those two answers. If x is 14.3, we get the absolute value of 4 times 14.3 minus 24.8 equals 32.4. Well, let's see here. 4 times 14.3 is 57.2 minus 24.8 is 32.4, and the absolute value of 32.4 is 32.4. So that one's correct. Okay. Second one, checking that. Absolute value of 4 times negative 1.9 minus 24.8 equals 32.4. So we have 4 times negative 1.9, which becomes negative 7.6, and then minus 24.8 more, we get the absolute value of negative 32.4, which is 32.4, and 32.4 equals 32.4. So it checks. Okay. Let's take a look at one that has fractions. Let's see here. The absolute value of 3x over 5 plus x over 2 equals 6/5. Now, what I can do before I split it up into two separate equations to make it easier, I can take what's inside the absolute value bars and simplify it down to a single fraction. So let's deal with that. Let's see, the common denominator would be 10. So I got to multiply this by 2 over 2 and this by 5 over 5. That's going to give me the absolute value of 6x over 10 plus 5x over 10, which is going to give me the absolute value of 11x over 10. Okay, so I can simplify what's inside and break it, or combine it into a single fraction. So now let's start over and let's just take this, say, okay, we've got the absolute value of 11x over 10 equals 6/5. So 11x over 10 equals 6/5, or 11x over 10 equals negative, or the opposite of 6/5. Okay, now, how do you get rid of a coefficient that's a fraction? You multiply by its reciprocal. So we're going to multiply both sides by 10/11. The 11's reduced to 1s, the 10's reduced to 1s, and we have x equals. And then over here, 10 over 5 is 2. We've got what? X equals 12/11. Okay? Then here, the second one, we're going to do the same thing. We're going to multiply this by 2 over 2. So we're going to have, and wait, that's not what we're going to do. My bad. Sorry. We're going to multiply both sides by 10 over 11. 10 over 11. The 10s and the 11s cross out. We get x equals, the 10 and the 5 reduced down to 2 over 1. X equals negative 12/11. Okay. So we've got two possible solutions. X equals 12/11, x equals negative 12/11. Okay, so now I've got to go back and plug it into this original equation. I'm going to go ahead and go to the next page and recopy that. So I've got the absolute value of 3x over 5 plus x over 2 equals 6/5. And my two solutions are 12/11, negative 12/11. Okay, so let's check it out. Here we go. If x is 12/11, we get 3 times 12/11 all over 5 plus 12/11 over 2 equals 6/5. This does not look like fun, does it? Okay. So then what have I got? Well, let's take this piece right here. 3 times 12/11 over 5 would be 36/11 over 5, would be 36/11 divided by 5, would be 36/11 times 1/5, which would be 36/55. Wasn't that fun? So this whole thing, 36/55 plus, okay, now let's take this, 12/11 over 2 is 12/11 divided by 2 is 12/11 times 1 over 2, which is 12 over 22, or 6/11. Still with me? Common denominator, 55. I got to multiply by 5 over 5. So I've got 36/55 plus 30/55, which is 66/55. But 66/55, I could take out an 11 and reduce it down to 6/5. The absolute value of 6/5 is 6/5, and 6/5 equals 6/5. So it works. Haha. Now, I'm going to save some time here to check. So I know that this solution works. To check this solution, how would that change our calculations? This would be negative, and this would be negative, right? Which means these would be negative, which means these would be negative, which means this would be negative, which means this would be negative, and the absolute value of negative 6/5 would still be positive 6/5. How lazy can I get? But anyway, so they both work. All right. So for tonight, you've got section 8.5, and I will be back at 1:15 with an office hour. Should you panic and have need of me, or maybe you don't panic, but you still have need of me. Anyway, have a great weekend. And with that, we will stop the recording